All right. On this part here, we are going to be talking about some different numbering systems, because our system, we like our system, but if you think about it, that system that we use for numbers hasn't always been around. Of course, people have been counting from way back, but they maybe use different numbering systems than we use. They did use different numbering systems. So we're just going to talk about some early ones. There were others. The book talks about some others, but these are the ones I like to talk about. We're going to start with the Egyptian system from about 3000 BC. This one's from. And interesting, yeah, they had some interesting symbols. Their one was just kind of a one, just like ours. They call it a stroke mark. Equals our one. Okay, so that's good news. Their one looked like our one, pretty much. However, their symbols did not include a symbol for 2 or 3. If they wanted to do 2 or 3, they would just do 2 stroke marks or 3 stroke marks, or 5 would even be just 5 stroke marks. I don't even think they did we sometimes do the 4 and then a slash for the 5. Maybe they did that. I don't know, but we could check that. But they didn't have anything for 2 through 9, matter of fact. They would just do stroke marks for 2 through 9, 2 strokes, 3 strokes. No, they didn't have another symbol till 10. And I guess we call it by name. We call it the heel bone. It kind of looks like the back part of a foot is where maybe they get that. But that was their 10. The heel bone mark was worth 10. And they're similar. Our system is base 10, right? We have what we call base 10. We'll talk more about that in a moment. But theirs was a base 10 also. They went by power. That just means we use powers of 10, and they did too. The next mark was for 100, and it was the scroll, or what we call it was the scroll, because it resembled kind of an unraveled scroll there. But yeah, it went to the next power of 10, which is 100. Then, of course, what would be next? 1,000? 1,000 was this little flower-looking thing, supposed to, lotus flower. That was 1,000. And then 10,000. Well, that's really going to test your drawing abilities there. It's supposed to be a pointing finger. I failed that test for sure, but I used to could draw better than I can now. But I haven't done it in a while. But anyway, yeah, they had different symbols for their numbers. Okay? And this was a few of them. I think on the sheet, I do have a sheet there at the bottom of the sheet, the information sheet I call it. There's a couple more, don't I have? Yeah, there's like a whale and I think they call it an astonished person, but I'm not even going to try to draw those. But they did have some others. I think this will get us by with what we'll do. So anyway, these were their symbols, or some of their symbols. Now, the good thing about it was, in their system, all you had to do was add up the symbols that they had, and that was your number. For example, if I had 2 scrolls, 3 heel bones, and 4 tally marks or strokes, that's what? Scrolls 100, heel bones 10, those are 1, so 234? Okay. So their system was easy in that regard. You just add up the symbols. In other words, they didn't have any place value. Like in our numbers, if I say 5,261, yeah, that's 5, but it means more than 5, doesn't it? It means 5,000 because it's in the thousands place. Well, they didn't have that. This being here didn't mean anything different than, yeah, what would this one be? How much would that be? Well, I got 234. It's the same number, okay? Yeah, their symbols didn't have any place value whatsoever. In other words, it wasn't positional. Their system was not positional. The position of the symbol did not mean anything. The scroll was 100, whether it was here, at the end, at the front, in the middle. It doesn't matter, okay? So their system was less complicated, I guess you might say, than ours. One thing I like to point out on the Egyptians was they did have a rather nice way of multiplying. Of course, they didn't have calculators at that time, so they had to devise different ways of calculating stuff. And let me just show you here the Egyptian method of multiplication, or one of them. The Egyptian method for multiplying. We'll just also mention it's called successive duplication. Because that's essentially what we're going to do. All right, so let's say I was going to multiply the numbers 19 times 36. Easy for us these days, especially if you have access to calculators, which phones have calculators now, so very easy to multiply things. But back then, back in the day, the Egyptians' day, wasn't so easy. Here's the way they would do it. What they would do is they would take the larger of the numbers. Of course, I'm using our numbers now. Of course, they would have theirs and heel bones and stroke marks and all that, but I'm just going to use our numbers. What they would do is they take the larger number, which in this case is 36, and then write a 1 beside that. So if it had been 19 times 45, we would have put 45 with a 1 beside it. So whatever the larger number is, put a 1 beside it. Okay? Called successive duplication because what we're going to do is we're just going to start doubling. And we're going to continue doubling until we don't need to double anymore. I'll tell you why that is in a second. All right, so I just double the number. Now, why would that be easy for them? Well, you're talking about 3 heel bones and 6 tally marks. Well, we could double 3 heel bones and 6 tally marks very easily because that would give us 6 heel bones and 12 tally marks, and then we could combine them to make some heel bone out of those tally marks. But anyway, doubling was easy. So that's, all right, so if I double, it gives me 72. Double here gives me 2. All right? So we're just going to continue doubling, like I said, until a certain point I'll tell you about in just a second. All right? So I double again, 144. Double again, you get 4. So I just keep doubling down here. All right, so 8 and 288. Now, there is a stopping point here, and the stopping point is when I can get these, or some combination of these, to add up to be 19, the other number. I can't add those to be 19 yet, right? 15 is all I got. So you keep doubling until you can make the 19 out of those. So I need to double once again, don't I? Double the 8, you get 16. Double the 288, that's 576. Okay, so now it's more than 19. So here's what I do, is I just count the ones that add up to be 19. So that would be 16 and what? 2 and 1, right? That would be 19. All right, so I'm just going to count those. Well, to get the answer, though, that I want, what I do is I count the ones that are directly opposite of those. So these add up to be 19. So if I add the ones across from those, should be the answer 19 of 19 times 36. Let's see. So 36, 72, and 576. What do those add up to be? 108, 684? I do believe. Is that right? 36, 72, and 576 is 684. Anybody believe that? Is that okay? Just add the ones across from the 1, the 2, and the 16.
Okay, so just from the ones that
Yeah.
add up to
Just the ones that add up to be 19. Those are the only ones I add up over here. If I'd used the 4, then I would have added the 144. Is that 684? Is that right?
Yep.
Somebody hadn't told me yet, so I want to make sure. All right. Okay, well, we can quickly check that now, because what does your calculator say 19 times 36 is? 684. Okay, so there you go. That was their way of doing calculating. Well, they didn't have calculators, so the other thing, if you want to do 19, you'd have to do 36 19 times. So if you think about it, that was an easier way of doing it, you see. Just a few numbers as opposed to 19 of them.
You took 576, 72, and 36.
Yep, those three added together. Okay. All right, so that's that's the Egyptian system. A little bit different than ours, wasn't it? Well, all these are a little bit different. The other, there's three of them I want to talk about. The second one, let me talk about, is the Babylonian system. And interestingly enough, their system had only two symbols. It was a symbol for 1, which is, they used a wedge. And they used a double wedge. Wedge, two wedges angled together like so or something like that. Okay. For 10. That's all they had, symbols. Well, if you think about that, that's going to be hard if we just have those symbols alone. That's going to be hard to make big numbers, because if I just was using 10 straight up and 1, what if I had 2,465? Well, that's a lot of double wedges. Okay, they actually they had a little more complicated system. They added a little something to it. It turns out they also used what we describe as a base 60. Here's what here's what that means. What they did is, kind of like ours. If this, using my number here, 5,261, this means 6 times 10, doesn't it? 60. And that's 2 times 100, 200. Well, they would do the same thing, but they would use a base of 60. Here's what I mean. Let's say I had, if I just had a number like that, yeah, that's straight up. Double wedge and 3 singles, that's 13, okay? However, what they would do is if they had a double wedge, say 2 double wedges, and let's say 1 single wedge, and then they had another group here of a double wedge and then 5 singles. They would put them in groups like this. And what it would mean is, this, of course, is the 15, right? And this, of course, is 21, 10, 10, and 1, right? But this group here would be, and that's where the base 60 comes in, they would multiply this one by 60. Now, why 60? I don't know that anybody knows for sure. It's been speculated that it was 60 is divisible by a lot of things. It's divisible by 2 and 3 and 4 and 5 and 6 and 10 and 12. But it's just a nice number, they thought, I guess. But it was base 60. They used 60 as this number here. So that way they could get bigger numbers out of fewer symbols here, because if you multiply the 21 by 60, that's going to give you what? 1260 plus the 15 is 1275. 1275 in our numbers. Okay?
So the base will always be on the left.
Yeah, the base, the one that's 60. Yeah, the first one on the right is just the straight up, just the symbols, and then the next one over is times the 60. Now, what if we went one more step further? Set it a double, double, 3 singles, double, 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 single, and then double, and 4 singles. Okay. All right, so we've got 3 groups there, don't I? Got this group, and this group. Well, this one, just straight up, whatever it is, right? 14, 10 and 4 ones. All right, what about this group? Well, we got 31, but it's the second group here from over. So we've got to do what? Multiply it by 60. Yeah. But then I have the third group, which is 23, and, well, it's not going to be multiplied by 60 because we've already got that group by 60. No, we've got to go, increase a little bit. Just like ours, we go up, we go 10, hundreds, thousands. Theirs goes up basically the same way, but with 60s. So what do you think here? Yeah, most people would say 120. However, we're talking powers of 60. So we're talking the second power of 60, which is not 120. Yeah, it's 60 times 60, which is 3,600. So yeah, they would multiply that next group over by 60 to the second power, which is 3,600. So I'd have 23 times 3,600, 31 times 60. Is that okay? $82,800. 31 times 60, 980, 14. Is that right? And then add those together. What do you got? 84. Huh? Did I do it right? I get 84,674. That ain't right. Let me try that again. 23 times 3,600. Plus 83,794? Yeah, okay. I did something wrong that first time. Okay. All right. Now, so that's how we determine what number they have. What if, say, we wanted to take one of our numbers and convert it to Babylonian?
It's going to go to the left. It's never going to keep going to the right. So
What?
you know to start at right and go to the left.
Yeah. This one will always be, the one on the right will always just be straight up, whatever they are. And then you just go up. Yeah, so let's convert our number to Babylonian? All right, well, that's a little different story, isn't it? We don't have the symbols there to just convert over. We have to think about it a little bit. Well, hopefully, fairly obviously there, I'm going to need two groups. Two parts, right? Because the second group basically kicks in when you get bigger than 60. Now, why don't I know I have a third group? Well, the third group would kick in when I have 3,600 or bigger. This was just 1274. So I just have two groups. The first group is, I'm just going to have a two-part Babylonian number here. The first group is the 60s. What we multiply by 60, right? Well, to determine that, what we do here is just take 1274 divided by 60, and let's see what how many times 60 goes into it, basically, is what we're asking. 21.23 is what I get. So evenly, 60 goes into 1274 21 times. So that tells me 21 needs to go here. I'm going to put 21 in that first group. Now what goes in the second group? Well, in the second group, since this group will be 21 times 60, that is 1260. So what goes over here? Well, if I want to make 1274, yeah, I better put 14 over here. So 14 would be the double and 4 singles. Okay? So yeah, to convert the Babylonian over, convert our numbers to Babylonian, divide it by 60, and then you got it. Go from there. Okay? All right. The third